Good morning to all of you. Let us wait for another 1 minute, 2minutes. That only nine people have joined. So let us wait for the others for 1 to 10, 1 to 2 minutes. Okay, so let us start. So today we'll be discussing about the interrupts and polling that is already there in the 8051 microcontroller, that there are some differences between the interrupt and polling, but this is very important in case of the 8051 microcontroller. So there are two ways by which a microcontroller can serve several devices. So they are interrupts and polling. So if we go by the definition, it comes like the program associated with interrupt is called interrupt service routine. Many devices can be served by assigning priority, not at the same time. In interrupt method, the microcontroller can ignore a device or request for service. Okay, and in case of polling, the microcontroller continuously monitors the status of the given device. When the condition is met, it performs the service. The main disadvantage of polling is that it wastes much of time of the 8051 microcontroller. And in polling, it is not possible to assign priority. Okay, and obviously there will not be any, just a minute. So ignore a device service for service, since polling method checks all devices in a round robin process. So if we take an example, real life example, like I'm taking your class, I'm giving a lecture, and you people are listening. So if such kind of activity happens, like mm, while giving the lecture, you someone of you, or not someone, uh, five people among you ask me that, sir, what is that? Okay, five different questions I have received. You have asked five different questions. So what do I do? So what I do, that I'll take the first question, I'll take then I'll take second question, third question, fourth question, and fifth question. Likewise, okay. So this is the interrupt. This is an example of interrupt, and in that case, I mean, sometimes it happens that I'll take the third question first, then fifth question second, first question third, like this way. So I'm giving the priority to the questions that are already asked. That means the interrupts that have been came to me, I am the CPU, and I am deciding that what interrupt is important, more important than the others. So I am assigning a priority to them, and I'm getting the queries cleared, or the interrupt that is serviced. Okay. Now, for example of 8051 microcontroller, we will clearly find out that there are five interrupts that are. We'll come to that again. There are five interrupts that are available in the 8051 microcontroller. Okay, and this 8051 microcontroller is having two external and three internal, these interrupts. Okay, so we'll come to that. And polling, what is polling? That every time I'm giving some lecture on some topic, and after that I'm asking that, do you have any question? Do you have any question? Do you have any query? So continuously I am asking and looking for the questions or query raised from your side. Okay, so this is polling. So suppose I've given some lecture on some topic, and there are no queries at all, but still I'm asking that, is there any query, is there any questions? So this waste time. Okay, so this interrupt is obviously interrupt saves much time of the 8051 microcontroller. Okay, rather than in comparison to the polling process. Okay, understood? Okay, so we are going forward. So there are some
Sir,
steps.
one question is there.
Yeah, please tell me.
So, what is the round robin process?
Round robin process means suppose there are five interrupts. So not five interrupts, forget about the interrupts. There are external signal sources. Okay, suppose the number of the source is 10. So this microcontroller will go like first 1 2 3 4 5 6 7 8 9 10, and again 1 2 3 4 5 6 7 8 9 10. This process continues. Okay, this is the round robin
Okay, sir.
process.
Okay, sir.
Okay. Sorry. So these are the steps that for the executing the interrupts. The activation of an interrupt, the microcontroller goes through the following steps. Okay, so there are five steps. So at first, it finishes the instruction it is executing, currently executing, and saves the address of the instruction on the stack. As you know, that the next instruction to be executed, that address is stored into the program counter. So the program counter address will be pushed onto the top of the stack. Okay, and if there are some interrupt received, then saves the current status of the all the interrupts. Okay, and number three is the jumps to a fixed location in memory called the interrupt vector table that holds the address of the interrupt service routine. Okay, so this service routine, that interrupt service routine, suppose uh, you are at you are there in the at your home, and some guest comes in your home. Okay, so what you will do, you will do like you will welcome him or her, and you offer him to sit or her to sit, and you'll offer water, tea, biscuits, and some snacks, and you'll do some conversations, and after the conversations, he or she will leave your house. So this is the total thing. If you do like for every guest, this thing you repeat. Okay, so this is the default activities done by you when a guest comes. So guest coming is an interrupt, and whatever you are doing with the guest, that is the interrupt service routine. Okay, and whatever you are doing just before the guest arrives, these, suppose I mean you are solving an assignment, then the guest comes. So question number up to question number 2 have you have solved. Before starting question number 3, the guest arrives. So you will put the things aside, and you will perform your activity that needs to be done while addressing the guest. So after the addressing of the guest, when the guest leaves, then you will come back to your assignment, solving the assignment from question number 3. So this is the default program, that whatever current program you are doing, that was stop, not stop, that is paused, and the next next question, that is to be next problem to be solved, that was done just after the guest leaves. Okay, so in case of microcontroller, whenever a program is going on, if in between if some interrupt is received, then the original program, the current program, the next instruction to be executed, that address is pushed onto the top of the stack. Okay, and the interrupt service routine executes. After that, again the address that was stored into the top of the stack, it comes back to the program counter. Okay, now the microcontroller gets the address of the interrupt service routine. This just a minute. So this ISR that means the interrupt service routine. Okay, from the interrupt vector table. Okay, there are some vector tables that are already available in 80852. In every cases, this vector table actually stores the program, and whenever an interrupt is received, by default, the from the interrupt vector table, the address was copied from the vector table to the program counter. Okay, and jumps to it and start to execute it. Then at the last stage, whenever return RATI, that means return from the interrupt service routine to the main program. So the microcontroller returns to the place from where it was interrupted and starts to execute from that address. Understood the steps? Okay. So there are some interrupt programmings. An interrupt is an external event that interrupts the microcontroller to inform it that a device needs its service. The 8051 has 6 interrupts, 5 of which are user accessible. Okay. Now we will see that what are the 6 interrupts and why we call that the 5 interrupts are there in the 8051 microcontroller. So actually, if we do it, if we look it into the, in a much serious manner, then we can see that one is the reset. Okay, so what is reset? Just think about it, that whenever we are pressing reset switch, or we can do what just like whenever a high voltage is given to pin number 9 of 8051 microcontroller, then 8051 jumps to the address location 0000H. Okay, so apart from the stack pointer, every register, every memory location has been reset to 00. Okay, now there are two interrupts that are set aside for the timers. As you know that there are two timers that are available, timer or counter is available in the 8051 microcontroller. So there are two interrupts can be generated. Okay, now just you see that one for timer 0 and one for timer 1, that is already there. So you can see this 000B is for timer 0 and 001B, that is timer 1. Okay, so these are two interrupt vector tables that are available. So whenever some interrupt is received from suppose timer 0, then just a minute. Yeah, if any time if any interrupt is received from timer 0, then automatically the microcontroller program counter value will be 000BH and it starts counting from here. And at the end of this particular timer 0 interrupt service routine, there is a option, there is an instruction, that is RATI. Okay, we'll find like RATI. Clear? So return interrupt that includes actually this helps the program back to the main program. Okay, understood or not? Any questions you can ask? No questions? Okay. So we are going forward. The two interrupts are set aside for external hardware interrupts. Memory location 0003H and 0013H in the interrupt vector table belong to INT0 and INT1 respectively. So we will see see a table that that is the interrupts and their vector table locations, memory locations, in the next slide. I mean upcoming slide. So the serial communication has a single interrupt that belongs to both receive and transfer. So there are transmission and reception pin, but the interrupt, as we know that at a time, at a time, one microcontroller can be a transmitter or a receiver only. Okay, so these interrupt vector table locations 0023 belongs to this interrupt. Clear? Okay. So till now there is any questions? Any questions you can ask.
सर स्क्रीन शेयर हट गया सर. सर स्क्रीन शेयर हट गया सर.
अच्छा, sorry. Yeah, now it is okay?
Yes sir.
Okay. Now if you are having any questions, you can ask.
Sir, the memory location 0023H that can receive and transfer both.
Yes, both. These are, this particular memory location is, allocated for receiving and transmitting both.
Okay, sir.
Okay, so we are going forward. That the interrupt enable register. This interrupt enable register, as you can see, this is a 8-bit register, and obviously this is not bit addressable. If you can remember the structure of or the architecture of internal RAM that is located in the 128 bytes of memory on chip with the 8051 microcontroller, we will clearly find out that this IE register or the interrupt enable register is the not bit addressable register. Okay, so whenever we are activating or we are using this register to program, we need to give or we need to load by the 8-bit data, with under which you can see that D6 bit or the 7th bit is ignored. Okay, so this is made by the manufacturer. You can see this interrupt enable 6 pin is not implemented and reserved for future use. So what is the future use? That user software should not write once to the reserved bits. These bits may be used in future flash microcontrollers to invoke new features. So just make it very clear that 8051 microcontroller future use, it is not mentioned, but it was developed for adding more features to the next upcoming families, okay, or upcoming versions of 8051 family. Okay, but in 89C51 microcontroller, this particular external this interrupt enable register, D6 bit or the 7th bit does not hold any value. Okay, now at the starting from the most significant bit of the interrupt enable register, that is IE7, that is disable all interrupts if EA is 0. That means this is enable access. Okay, enable access. Just like the masking and unmasking of 8085 microcontroller, if suppose the guest comes to your home and you did not open the door, okay, so what happens? As if you are not there in the home, or in case you are really really not at your home, you are out of your home, and some guest comes, so he presses the bell 1 or 2 times and see that okay, I think he is not available, he or she is not available, and the guest goes back. Okay, so this is the masking thing. That means whatever the interrupt comes, but this is not acknowledged by the not received or not acknowledged by the 8051 microcontroller. Okay, so if this particular bit is 0, then what happens? What happens? If this particular bit is 0,
The interrupts are not acknowledged. Yeah, acknowledged.
yes. And Tanisha, what happens if this is 1, Tanisha? Tanisha is not there. Okay.
Yes, sir.
Where were you?
So here only.
I don't think so, because by to unmute yourself, this that much time is not needed. Now, what is my question? What is my question, Tanisha? Are you listening or not?
Yes, sir.
What is my question? You know or don't know?
Sir, don't know.
So you need not to unmute you. I mean, mute yourself every time. Once I told you to, I tell you to mute yourself, then only you can mute. Okay. So whatever we are discussing,
So IE register.
which bit, which particular section?
So 6. IE 6.
Can you show your copy?
Yes, sir.
Show me. Okay, you can turn off your camera. So you should draw this actually, otherwise how can you understand? You should draw
Okay,
this in
sir.
your copy.
Okay,
So
sir.
whatever we are discussing, that whenever this EA pin is 0, then all the interrupts will be disabled. That means any interrupt comes, the CPU will not process any interrupts. Okay, and if it is 1, then this particular, depending on the source, it will be jumped to the particular interrupt service routine. Okay, and this can be individually addressed to. There is a pin, you can see this ET2. That ET2 is nothing but the external, just a minute, yeah. So this timer 2, okay, enables timer 2 overflow or capture interrupt. So as you know that there is no timer is, only 2 timers are available in the 8089C51. So this particular will not be available at 89C51. Okay. But if any question comes onto this particular 8051 IE register, then you can write it. Okay, you should write this. So this ES, that means the serial port interrupt. There's nothing to say. Whenever we are enabling this particular serial communication port, then it should be 1. If we want to activate this particular ET1, that is for timer 1, then it will be 1. EX1, that means the external interrupt coming from the INT1. Okay, and this is for timer 0, this is for interrupt 0. external interrupt. Understood? So this is very simple, because just keep in mind that I'm clearing everything. Just keep in mind, unless and until this EA pin is activated, this all the things will not be recognized. If this is zero, if this is zero, this EA is zero, then what happens? All the things here will be automatically zero. So before activating any interrupt, we need to activate this external access pin. Okay, understood? Okay, we are going forward. So as we have we have discussed that there are some vector tables for 8051, and this is the vector table. You should write over your copy that whenever we are pressing reset, the ROM location will be at 0000H. Whenever an external hardware interrupt is set to, any interrupt comes from the interrupt 0 anti-0 pin, then it jumps to 0003 and so on. Okay, understood? And we have already discussed that there are serial communication interrupts. You can see this serial communication interrupt, as we know that these two, receiving and transmitting, these two are of same interrupt. And obviously this particular, whenever a transmission interrupt or receive interrupt that occurs, then the interrupt service routine starts from 0023H. Understood? Now, if you have any questions, you can ask.
Sir, please repeat the last section, serial com interrupt R1 and T1.
This not R1, actually this will be RI. Everywhere it is written RI. So this is RI and TI. Okay, this receive interrupt and transmit interrupt. So as we have discussed, just like in the previous slide, you can see, you can see that serial communication has a single interrupt but belongs to both receive and transfer. Okay, just we have put this thing that for receive and transmit interrupt, the interrupt service routine will be from 0023H. Okay. So another thing that you can see, that external interrupt, these two external hardware interrupts are there. So some pin numbers has been mentioned. Okay, so this pin number and this pin number has been mentioned. Understood? But apart from this, all other, these three interrupts are internal interrupts, so no pin numbers has been mentioned. Understood?
Yes, sir. Software
Yes, sir.
interrupt.
Okay. So this is a program. I think we should go. I mean, we should not discuss it by today, because it is not that much time left. I think a couple of 7 to 8 minutes left. So by the time, if you are having any queries regarding this particular interrupt and polling section, you can
Sir.
ask. Yeah.
Sir,
Yes, ask.
my question is from previous class, sir. You have given us 2 questions for homework.
Yes.
Sir, in which the first question was, I have doubt in the first question. Write a program to transfer the message fine serially at 2400 baud rate, 8-bit data, 1 stop bit.
Yes.
Sir, I have transferred the first character F. Then I'm facing problem in creating a sub program, a loop in which I can transfer character I, N, and E. Can you please make me clear about the subprogram?
Look, at
Transferring all
first,
the
let me tell you, at first, let me tell you that, let me tell all the people, you need to transmit this fine. Okay. So for this, if you first transmit this F, then at the receiver side, the F will be received at first. Okay. Then you transmit I, then it will be I, then N, then it will be N, and this will be E. So do you understand that what is the problem at the receiver side?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Bit is
yes.
just
So first you need to transmit E, then N, then I, then F. Okay. Not first starting from this side. Start from I, from the rightmost side. Okay. So first you need to transmit this. Okay. So in the receiver side, at first E comes, then N, then I, then F. Okay. So you are having problem that how to transmit. That nothing, no problem is there. Just you can see this particular section is
common in all
common.
of these.
Okay.
Yes, sir.
Okay.
Okay, sir.
And
No,
sorry.
sir, baud rate should be different in move th1 hashtag 0f. It should be different for a different baud rate.
No. I'm not telling you about the baud rate. I'm just telling that the section, this value will be changed. This value will be changed. Okay, no problem. This will be there. Okay. Sorry, this value will not be changed. I'm sorry. This value will not be changed. So this value will be changed. Okay, fine, no problem. But I am telling that whatever write in your program to transmit E, that will be same for NIF. Okay.
Yes, sir. Yes, sir.
So you will write once this portion, this initialization portion, and you repeat this portion for 3 times. I mean, not 3 times, 4 times. For E, 1 time, then come to move, again write move sbuff, comma, hash, ASCII character N, then ASCII character I, and so on. Clear?
Yes, sir. Sir, I have done a solution. Can you please check it out whether it's wrong?
Yeah, please, sure. You can share. Just a minute, Aditya.
Can you see the? Okay, sir.
Yes, I can see it. But please record your this attendance by the time, because time is short. Yeah. Your video is not coming. Yeah, tmod 20 F450 set bit tier 1. Yes, first it will be first F, not F. First will be E. Okay, then N, then I, then F.
Yes, sir.
Okay,
Okay, sir.
here JNB TI here. Here TI is jump again. No. This is jump again. If you put S jump again, then it will not move forward. And what is the again loop has not been labeled.
Oh, yes, sir. Yes, sir. Yes, sir. Yes, sir. Jump
Okay.
have, sir. I have to write S jump here.
Not S jump here, because it is an infinite loop, so it will not come out of the loop any time. So remove this S jump
Okay,
again. Okay, so infinite loop means ये तो वो लाइन से बाहर नहीं आएगा कभी. Okay.
Okay,
Sir,
Yes.
सर ये JNVTI हेयर वाला बार बार यूज करना पड़ेगा.
हाँ, बिकॉज जब तक ना ये पर्टिकुलर जो देखो ये ASCII कैरेक्टर का कोई हेक्साडेसिमल इक्विवेलेंट वैल्यू है, ठीक है. तो हेक्साडेसिमल इक्विवेलेंट वैल्यू ये 8 बिट का होगा.
16
ठीक है.
बिट. हाँ सर.
हाँ, तो ये 8 बिट जब तक ना ट्रांसमिट हो जाए तब तक ये हमको वेट करना पड़ेगा.
चलते रहेगा.
ठीक है, लूप चलते रहेगा. वो खत्म होगा, फिर बाहर आएगा, तो नेक्स्ट कैरेक्टर को हम भेजेंगे. ठीक है, लाइक दिस.
उसी में से उसके बाद सर TI हो जाएगा सर.
एकदम लास्ट में जाके तुम एस जंप अगेन दो, कोई प्रॉब्लम नहीं है, या एंड दो, कोई प्रॉब्लम नहीं है.
ओके सर.
ओके.
ओके सर.
Okay, so you please record your attendance just because there is less than 1 minute remaining.